Okay, so in the second assignment notebook, we will play with stock price data. Now under the data folder, you will see this stock price data files. Yeah, we can see them, right? So each file have two columns, right? The first column is date, the second column is stock price, right? So we have the stock price for Boeing, Coca-Cola, General Electronics, IBM, as well as P&G. Now, if we take a closer look at the data, we will see that there is one record per month, right? One record per month, starting from 1970s to the end of 2009, right? So this is a very long term, we call time series data, and we have 5 of this time series in this data set. So in this assignment notebook, we will learn how to handle the time series data and how to visualize them with line plot, right? Now, actually, because there are 5 series of stock price, so we will draw multiple lines in the same plot, and we will add some assisting line to facilitate the comparison. And besides drawing multiple line plot, in this notebook, we also want to learn about how to apply function to the collective objects, so that we don't need to write the same code repeatedly for every data object one by one. As we have done before, we can read each of this data file into a data frame, right? But instead of keeping this data frame separately, we can keep all of the data frame in a list and call the list L, right? In this way, we will have a collective object. In this way, we will have a collective object L, which is the list of 5 data frames. After we have a collective object, we can actually use the built-in function lapply to apply a function on each element of this collective object. Okay, for example, we can apply this function class to every element, to every sub-element of the list L. So as we can see here, that it would tell us the data structure of each of the IBM, GE, P&G, and so on. The output of lapply is another list, right? And sometimes it's not so easy to read a list, right? Because it's quite complicated. So sometimes it would be desirable to simplify the output of list. And that is why we have a function called sapply. Now, sapply is do the same thing as lapply, plus it will simplify the result whenever it's possible. For example, this list can be simplified as a vector, isn't it? Right? And if we apply name to every one of this data frame, right? Because every one of this data frame have 2 columns, right? And the column name is always data and stock price, data and stock price. So sapply is going to simplify the output so that instead of returning a list, it would return a metric. So it's easier for us to observe, to examine the output. In lapply, instead of using the built-in function like class, like names, we can also define our own functions, right? We can define our own function so that we can convert the column date from character string into a date type, right? So in order to do that, we only need to write the code once, right? And apply the same function to every data frame inside L, right? Now consider you have a list of 500 stocks, and in that case, writing one line of code for each of the 500 would be very cumbersome, isn't it? That's why we need the functions like arrowApply and sapply, right? Because it will help us to do this repetitive action a lot easier. As I mentioned at the end of this notebook, actually using tapply, arrowApply, and sapply to do the repeated operation on data is a key feature in R programming. And in this Ninja's Dojo, I demonstrate how to combine tapply and sapply to calculate the monthly average of each of these 5 stocks, right? It will become a matrix because this is the monthly average of each of these 5 stocks. So as long as you can learn how to use tapply and sapply and combine them, you are becoming a good R programmer already.